Hi everyone, just a little quick update. This is related to the previous video, which is test 2. And what I've done is I'm just trying to get to understand really what's going on. So I've put my scope probe, unfortunately I got just one channel operating. So I put my scope probe across the bulb here, and we're going to see what happens when we flip between just the bulb, resistive bulb only, and the resistive bulb and diode back and forth. And I've got my same circuit, and what I've found is actually it's basically the pulse width that will give you the effect that, you know, basically with a really short narrow pulse we're not getting any power on the bulb when it's just the resistive bulb alone, and power when we're using the diode across. And that's having everything to do with basically the pulse width. So what I've done is I've adjusted my circuit so the pulse width is giving the same benefit for each side, and we're just going to look at the scope shot of that. So I'm going to start up the circuit by making a connection. So I'm going to just use 32 volts, a little lower voltage, and I'm going to show you the different scenarios. So first, the bulb is going to be just the bulb across the secondary up there, and then I'm going to flip it, it'll be the bulb and diode. And I'll give you a view of what the scope shot looks like, and you'll see that basically it is why the bulb is being lit on the other side with the diode is because it's the collapsing field that is energizing it, and that's why it comes at no cost to the input. So let's do that. Start it up. Okay, so now you see just a little bit of a glow there on the bulb. And then I'm going to flip it to the diode and the bulb, and it should be about the same. And we'll look at the data on the scope. That's just the bulb and bulb with diode. So if we look at just the bulb now, we'll go look at the scope shot, and that's what it looks like. So this is the energizing pulse of the coil, and then when the field collapses, then this balance is also going across the bulb. And if we look at the data there, we're looking at about close to 900 millivolts, so 870 millivolts. And now we are going to flip it over to the bulb and diode. And if we look, our data, we've got, well, a bit more, I guess it's a little brighter on that side, so 940 millivolts, and there you go. So now you're seeing that's the only thing that's powering that bulb, which is the collapsing field now that is powering that bulb. So basically that's why that if I make my pulse like really super narrow, the input pulse, well, the collapsing field is always the same, and that's why it powers the bulb. So got to get to finding out if there is a benefit of having a very narrow pulse and you know, powering something on the secondary without having an effect on the primary. So that's where the research is going, and thanks for watching. Bye now.